Today I'm going to show you how to use the cosine law and the sine law to solve for vector problems when they are not at right angles to each other. This is very useful for solving navigation problems. It's also very useful for solving force problem in static equilibrium. It's another method to use to understand how to solve vector problems. So take a look at these two vectors. One is a 65-kilometer vector above the horizontal. The other is a 92-kilometer vector that's below the horizontal. They're added head to tail. The angle between them is 140 degrees. And eventually, I want you to be able to find the resultant vector. And the resultant vector will be a vector that's going to go along here like this somehow. Okay? So in order to do this, though, you need to use two laws. One law, cosine law, is used to find the magnitude. And the other law, sine law, is used to find the direction. So let me show you these two laws. Now they're easy laws, they're from mathematics, and they look like this. So if you have a vector triangle, any kind of triangle for that matter, that has angle theta, angle B, and we can even put in here angle A if you want, then there is a relationship between three sides and an angle for this particular triangle. And the relationships is this. Vector R, the resultant vector, will be equal to side A squared plus side B squared minus 2 times A times B times cosine. Now the angle here has to be opposite to what you're trying to find. Since I'm trying to find R, cosine theta is the opposite angle to what I'm trying to find. That will give me the magnitude of this vector, but it won't give me the direction. Now, of course, I got to find R in here. So if I want to find R, I need to take the square root of this whole thing in there, and that will allow me to find R. If I don't take square root, I get R squared. Okay. Now on this side, this is what I use to find direction. I use what's called the sine law. Now the sine law says if I take a ratio of an angle, let's say B, and I do a ratio over its opposite side, in this case vector B, that ratio of sine B to vector B will be equal to any other angle, in this case sine theta, all over any other, or not over any other, all over the opposite length, which in this case will be R. Now since we use the cosine law to solve for R, we'll know R, we know what this angle theta is, we know what length B is, we'll be able to solve for angle B here, or sine of the angle B anyway, and then get B from this equation here. So this method, or this law, is used to find the direction, the sine law, and the cosine law is used to find the magnitude. Now let me show you how to do this with an example. I'll do two examples. One will be head to tail method on the actors, which will be very similar to this one here, and the other one's going to be tail to tail. Just show you what it looks like in a little bit different format. So here's the same example that we had at the beginning. 65 kilometers right at an angle above the horizontal, 92 kilometers some angle below the horizontal, angle between them is 140, and we want to solve for the resultant one there, and then we eventually want to solve for this angle. I'm going to call this angle alpha to call that angle in here. Alright, so let's first pull out the cosine law. Cosine law R squared will equal the value of A, which will be 65, you got to square that, plus the value of B, which will be 92 squared, minus then 2 times 65 times 92 times the cosine of the angle between them, and the cosine of the angle between is 140 degrees. Now that's the cosine law written out. So now we do the arithmetic that goes along with this, and R squared will equal, this number here will be 4225 plus 8464 minus, now cosine 140 is in the negative range. You're actually going to get a second negative sign in here. 916 1.89. Now, 2 negatives gives you a positive number, so you got to be aware of that. 2 negative gives you a positive number. In fact, you're going to get a point. So I'm just going to change this from 2 minuses to 2 pluses. And that means if I continue with this, r squared then is going to equal the square root of 21,850.89, and that means the magnitude of the vector r is going to be equal to 148 kilometers. That's using the cosine law. But remember, this is just the magnitude. So now what I need to do, I need to come back up here, and I need to use the sine law to be able to solve this problem over here. Okay? So to get to the sine law, I'll give myself a little bit more room. Let's go over here, and let's see if I can get down to this thing. Yep. Alright, sine law says, if I want to find angle alpha, so what I would do is that I would come along in here and I would go sine alpha. I'm going to divide it by its opposite, which would be 92. And that's going to equal another angle. Now, the only angle I know is 140, so I got to use that one. And I'm going to divide that by r. And since I solve for r, it's 148. I can use that right here. I hope you can see the only unknown here is sine alpha. So if I then go sine alpha, over a little bit, move this over now, sine alpha will equal, bring the 92 up, 92, you're going to multiply that by sine 140, and then you're going to divide that by 148. Now if I do my arithmetic correctly, sine alpha, there's a little space in there, comes out to be 0.3998. The arc sine then tells me that the angle of this, sine inverse, whatever you work out to be, is going to be 24 degrees. So now I have my direction, and remember what that is. That 24 degrees is this angle right in here. That's the 24 degrees. I have my magnitude right there. There's the r value for the magnitude. So I can now make one final statement. R equals 148 degrees at 24 degrees. I can say this above the horizontal, or would I just say this away from the 65-kilometer vector. And that would be my answer. And that will tell you that you're using this angle in there between the two. And that's good enough for now. Okay? The last example I want to show you by using the cosine law and sine law is when we have two vectors that are now positioned tail to tail, like these ones here, and there they are, tail to tail right there, and you want to find the resultant vector. Now remember, when we do this, what we need to do is complete the parallelogram. So I'm going to take a copy of this vector, and try to do that again. I'm going to take a copy of the vector, like this, and copy it. Well, maybe I won't copy it. I'll just draw another vector in here. There is vector A, and it's going to be a copy of that 8 Newton vector. And just make it as close as you can. Don't be exact, but close as you can. Label that. That is an 8 Newton vector. And remember, these two vectors are absolutely identical. And then I'm going to take a copy of this vector, and I'm going to put it over here. And we're going to label that as 15.0 newtons. These two are absolutely identical vectors, same magnitude, same direction, everything. The resultant vector then between these two has to go from where the two vectors start, tail to tail, all the way to where you have the two arrow joint in there, and that's where the resultant vector is going to be. You see, it's not perfectly vertical onto here. So we're going to solve for this vector here, vector r. Now it's not a right angle triangle, so we need to know an angle. Well, I didn't give this in the original question. I should have had written down, but this angle right in here between the two vectors 15, that's 150 degrees. That's the full angle in there. In order to solve for r, we need to know this angle here, but we can get that angle. If I take this vector here and just extend it out, just darn it out like that, I'm going to change color to a black color so you can see it. Okay, so there's that vector out there. I hope you can see that this angle is the same as that angle. They're exactly the same angle. That'll be 150 degrees. And if that's 150 degrees, you should be able to see that this will be 30 degrees because 150 and 30 should up to 180. Now we have the angle opposite to r. And if we have that vector, then we should be able to solve for r now. So vector r squared should equal vector 8 squared, remember, which is this one, plus 15.0 squared minus 2 times 8 times 15 times cosine of 30 degrees, right in there. Okay, now this is going to be a positive. Actually, you're going to actually subtract this out when you have that. So vector r will equal 64 plus 225 minus 207.84, the square root of, because you want r, not r squared. And that means that if you do the arithmetic, r should be the square root of 81.16, which is in fact equal to 9.0 newtons. However, just like before, that only gives you the magnitude. You need to find a direction. Now you can find either that angle or that angle. Let's go ahead and find this angle here, and let's call this theta right in there. So just like before, we're going to go sine theta divided by opposite to sine theta, which in this case is 15.0, is going to equal the r value that we know, and that value is 9. The opposite to value 9, which is sine 30, divided by the value of 9.0, which is the value r. We know this is now 9 in here. That means that sine theta will equal 15 times sine 30 divided by 9.0. That means that sine theta will come out to be 0.833 repeating, and the angle theta then comes out to be 56 degrees. Now remember what 56 degrees is? It's this angle right in there. So again, you need to make your final statement, and your final statement will be something like this: r equals 9 newtons at 56 degrees away from the 8 Newton vector. From 8 Newton vector. Now go on to the worksheet, give them a shot, see how you do.